आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. In this podcast, we are happy to present Dr. Saikat Biswas, experimental high-energy physicist from Bose Institute. He has invented a new kind of detector. Before going into more details about his research work, let's hear from his own voice about his academic journey.
I am Saikat Biswas. I am an experimental high-energy physicist here in Bose Institute, and I did my PhD at Variable Energy Cyclotron Center, which is a DAE institute in Kolkata. And there I worked on the development of one particular detector called resistive plate chamber for the proposed INO experiment. INO stands for India-based Neutrino Observatory. It was a proposed experiment, but there I did my PhD. I developed a new type of bakelite resistive plate chamber, which is kind of first of its type in India. And then I went to GSI Helmond Center, Germany. And there I also work on detector because my mission of working in this field is to develop new kind of detectors to study the inner part of the matter, what is called something like quark-gluon plasma phase and all, which is produced in heavy ion collision if you take the experimental part. And I also work on the detectors which can study for the study of cosmic ray physics. So at Bose Institute we have a program on the study of cosmic ray physics at our another center which is in Darjeeling. So there we have a large setup, and I also work on the experimental part of the research.
Dr. Biswas speaks more about his core area of research work.
I work on the physics of particle detectors. So this is a new kind of physics, you can say. Actually, detector is needed in any large scale experimental physics and in large experiment which is going on or some experiment which is coming up in future. And in all experiment, there is an experiment. After that, we need to detect the particle which is produced in the experiment, because we work on the experimental high energy physics, as you know the name. Actually, you can specifically tell experimental high energy nuclear physics. So what we do, we collide to heavy nucleus, or even you can say we collide to proton, and we want to see the inner part of that. If you collide to nucleus or to proton, then after the collision, large number of other particles or new particle can be produced. So after that, the main job of the experimentalist is to detect those particles. After that, once you detect the particle, you need to identify those particles. So these all part, first detection, then identification, all are part of the experimental high energy physics. Once you detect the particle, you find the track of that particle, then analyzing those data which is stored in your detector, in your computer, then using those data, you can analyze and you can extract new physics. So my part is to develop new detectors, characterize those detectors, first building the prototype and then make the large actual real size detector and to install in the experimental site. So I work in two large experimental facilities. One is the ALICE experiments, a large ion collider experiment at CERN, and another proposed experiment which is called compressed baryonic matter. Both the experiment will study the physics of quark-gluon plasma, QGP, which is a new physics. I will not tell new physics, but we need to study new physics using the experimental setup of these two experiments, CBM and ALICE. So this is one part. This is heavy ion experimental part. Another very important experiment is the study of cosmic ray. So in our Darjeeling campus, we built one small size, I will not tell a large size, but small size air shower array using 7 1 meter by 1 meter scintillation detector. So then, as I told the name, so I need to classify the detectors. What kind of detectors are present in the world right now?
Dr. Saikat Biswas speaks about different kinds of detector.
So basically there are three kinds of detectors. One is gas field detectors, which is the oldest. I work on it particularly starting from my PhD work. Then comes scintillation detectors, which is also very interesting. And another is solid state detector. So here currently at Bose Institute, we are working on the gas field detector and scintillation detectors. Gas field detectors are for the heavy ion experiment, and scintillation detectors, particularly plastic scintillation detectors, for the study of cosmic ray. Now, what is scintillation detector? As you know from the name, scintillation means kind of light, right? So when any charge particle comes, I have a detector material which is made of very common material. I will not tell common, but it is plastic, a special kind of plastic we use. Then if that particle incident on this plastic, it will produce some light. Now my job will be to collect that light, and from that light I want an electrical signal. So I build a detector, which is called the scintillation detector, where this produced light is converted to an electrical signal. And once I detect or collect or store this electrical pulse, then I can say there is a particle. So this kind of detectors we built 7 large size. 1 meter by 1 meter detector is not a matter of joke. So it is a large size detector. We assembled at Darjeeling those detectors, and now they are working for last 4 years. There was some gap during this COVID period, but still they are running well at our Darjeeling campus. So as I told, these detectors are for high energy physics, but there is always a possibility, not only a possibility, this is another my experimental next goal for near future, although I have worked on it in other institute before joining at Bose Institute. So there is a possibility of use such detectors in the medical imaging field. What is medical imaging? Imaging, you mean this is imaging, just make a photograph. But when you want to make a photograph of a very tiny particle, so you need a very good position resolution so that you can detect that particular image or article, what you want to image. So if in your body there is a tumor, let's say, so what we do, we insert some kind of radiation and we just detect the size of the tumor and all. Now, here also in your MRI and all, you detect those radiations and you identify the tumor or the size of the tumor using some detectors. We are proposing our detector, this RPC, resistive plate chamber, what we are building right now for the CBM experiment, what can be used also for the medical imaging. So we have reached a position resolution of the order of 5 to 10 millimeter, but I need even better resolution so that I can locate the tumor even in a better way. So this is an application of such a detector. Another thing we did in our lab, during this COVID period, there was some industries were closed and all, there was a lockdown and we passed through a bad phase. So that time our detector was on in our lab because those detectors can take data continuously. And we have made a correlation that with the pollution in the environment, the flux of cosmic ray which is coming at the earth is how it is changing. So we got some correlation that before lockdown, during lockdown and after lockdown, how they have changed. So we published a paper on it also.
Dr. Biswas speaks more about the rank of India in this particular research area.
On the development of detectors, India is, I cannot rank actually, but India is in good position because in the detector development, detector building, detector production and delivery in the large experiments. So from India, there are some institute. I will not tell large number of institute, but I can at least name some of our collaborators or friends from Bose Institute, VCC, Shaha Institute, Delhi University and Punjab University. So Delhi University and Punjab University, they are building already very large detector for the CERN experiment. VCC already produced detectors for CERN experiment and also for the experiment at Brookhaven. So we are in a good position, I can say, and which is comparable of the detector development and detector research of other countries, for example, Germany, France, Switzerland. The components of the detectors. For example, I am also working on a detector called gas electron multiplier. Basically, the gas electron multiplier foils, which is called commonly known as GEM foils, those foils were previously fabricated only at CERN. Now, there are Indian industries in Bangalore, in Hyderabad, they are making the GEM foils. And there are research papers where it is mentioned that those GEM foils are also very good at par of the GEM foils produced at CERN. So using those foils and other components to build detectors, everything we can build and there are a lot of industries here who are building and making the components of detectors.
We are thankful to Dr. Saikat Biswas for providing us with his valuable time.
Thanks a lot.